All right, we are talking about lesson 13.1, and we're talking about area. So we have to make sure we understand the difference, first of all, between what we talked about in the last chapter, which was perimeter, and now this chapter, area. So if I have a rectangle here, the perimeter is the distance around the rectangle. So if this is 2 and this is 4, we know that opposite sides of a parallelogram are the same, so this is also 2 and 4. So if I want the perimeter, let's say for example I want to build a fence around my property, or I want to know how much crown molding to put around a room, something that is perimeter, that's going to be just the length. I'm just going to add everything up, 4 plus 4 plus 2 plus 2, so that would be a perimeter of 12. Let's say this is inches, so that'll be 12 inches. If I want area, what I'm asking is how many square something can fit inside that. So if this is 4 inches, I'm gonna, and by 2, that means I'm gonna have 1, 2, 3, 4. Each one of these boxes here are gonna be 1 inch by 1 inch. So we call this 1 inch squared. So in this rectangle, I can fit 1, 2, 3, 4, 5, 6, 7, 8 square inches. Each one of these is a square, so I can fit in 8 inches squared inside that area. So perimeter is always just going to be inches because it's a length. Area, you always have to write the answer as a unit squared because it's how many squares that are that size can fit in that. You might do feet squared. How many 1 foot by 1 foot squares can fit inside a room? Or you might do mile squareds if you're talking about a country. This many square miles can fit inside that country. You use this for painting a wall. How many squares that are 1 foot by 1 foot will take up this wall? You use that for putting down carpet. You use this for the size of a TV screen, this many square inches. You can use this for a lot, for land, how many square inches in the land. All of these are very, very important things they use a lot. But for area, it's very important. All your labels for area always must be squared. If it's asking for a length, like the height or the width, those are not squared because it's a length. So we have 2 basic formulas in this lesson. If I'm talking about a parallelogram or a rectangle, the formula is simply base times height. Now, really, it doesn't matter in a rectangle which one is the base and the height. I could call this the base and this the height, or I could call this the base and this the height. Either way, I'm going to get the same answer, 2 times 4. In a parallelogram, you have, this is going to be the base, 12. Now, this is very, very important. For a parallelogram, the side is not the height. You are never going to use this number on the side for area. So always ignore the side number when you are solving for area in a parallelogram. You are only going to use the height. This is the height. It's a perpendicular, that means it makes a right angle line that goes from one base to the other base. The distance from one base to the other base perpendicularly, that's the number you're going to use. So never use the number on the side, only use this number. So I would do 12 times 6.6, and that would give me the answer. If I'm doing a square, I'm just going to do whatever the side is squared, because all the sides are the same, right? So I'm just going to do base times height, so it's always going to be side times side. So let's say I have a square with a side of 4.2 centimeters. So if I want to find the area, I'm going to do 4.2 squared. That's 4.2 times 4.2. So I would end up with, my answer for that would be 17.64 centimeters squared. If you forget that squared, you will get half a point off, so make sure the squared is on the centimeters. Now, do not do 17.64 squared centimeters. I don't want to square the number 17. I want to square my label because that's telling me that I don't have 17.64 square inches, a length. I have 17 squares that are each 1 centimeter by 1 centimeter. That's why you have to have the centimeter square. Let's say I have a rectangle and it says it's 8.5 by 4 inches. All you have to do is multiply those numbers together. 8.5 times 4, you end up with 34. And again, since it's an area, it's inches squared. Again, the square is on the inches, not on the 34. 34 inches squared. Let's say I have a rectangle and they give me the area and they give me one of the sides and they want the other side. Well, remember my formula is area equals base times height. So if the area is 75 and the base is 6 and it wants the height, all I have to do is isolate by dividing. So if it gives you the area and it gives you the base or the height, always divide the area by either the base or the height, and that will give you the other number. If it's asking for height, that's not an area, so your label, I'm going to do 75 divided by 6. That's going to give me 12.5 meters. This is not squared because it's not asking for the area, it's asking for the length of the height. Now, in your lesson, numbers 1 through 6, you're just finding the area of those figures. That should be really simple. If it's a rectangle, just multiply the length times the width. Multiply the two numbers. That's all you have to do. Make sure your label is squared. For numbers 4, 5, and 6, those are all parallelograms. So remember, you're going to do the base times the dotted line. Don't multiply by the side. So for example, for number 4, the base is 11, and you're going to multiply that by 6, not by 7. You're not going to use 7. So it's 11 by 6, so your answer would be 66 centimeters squared for number 4. So for 4, 5, 6, you're multiplying the base times the height. So the base is going to be the one that has the perpendicular line cutting it. So for example, the base for 5 is 2.8. The base for 6 is 7.8. Then you get the idea there. For 7 through 10, they just give you the base and the height. All you have to do is multiply. It's that easy. Just multiply and make sure your label is squared. Same thing for 11 through 13. Again, it's the base times the height, not the number on the side that's curved. Not that one, the straight up and down number. That's what you're multiplying by. For numbers 14 through 21, they give you the area and either the base or the height. So all you have to do to find the other answer is divide the area by the base to get the height, or the area by the height to get the base. And remember, for numbers 14 through 21, since it's asking for the base or the height, your labels are not squared. They're just centimeters or inches. They're not squared because it's not asking for area, it's asking for the base or the height. For numbers 22, 23, 24, I'm going to show you a couple of these examples to give you the idea of how you do this. So let's take this one here, for example. Notice this is a complicated figure, but really all it is several different rectangles. So what I'm going to do is I'm going to divide it into 3 rectangles. 1 rectangle, 2 rectangles, 3 rectangles. Now notice I have 8 on the top, and it's the same length as the bottom, so I know this is 8, 2. So then all I have to do is 8 times 2 to get this, 8 times 2 to get this. Now, what about this right here? Well, I know this whole thing is 8. I know this is 2 and this is 2. So 2 plus 2 is 4. So what does this have to be? Well, 4 plus what equals 8? Well, this is going to be 4. So the area in the middle is going to be 4 times 3. So then, once I get this area, 8 times 2, this area, 8 times 2, and this area, 4 times 3, I just add them all up, and then that's the answer for the whole figure. So anytime you have a more complex figure, divide it up into different rectangles and find the area for each rectangle, and then add up all the rectangles to get the whole figure. Sometimes you're going to be missing a part. So this one, it just wants the area around here. Well, that's going to be the area of the whole thing, 8 times 7, minus the area that's missing, which is 3 times 3. So just do the whole thing, 8 times 7, and then subtract the missing area. This is a combination of both of those. You can do this in different ways. I'll show you one way to do it. I'm going to divide the rectangle here. So I'm going to find the area of this rectangle. Now, what is this right here? It's not 5. We know this is 4 and this is 5. So from here to here is 5. From here to here is 4. So what is this missing area right here? If the whole thing is 5, this is 5, and up to here is 4, then how much is that? You would multiply that by 5 to get this area. Then, to get this, notice that from here to here is not 5, it's 4. times this will give me the whole thing, but then I have to subtract the area of that little missing portion. So once I get this area, I add it to this area, and that gives me the area of the whole figure. Don't forget to do the problems on the next page, 28 through 31. All of those are just rectangles or parallelograms where all you have to do is multiply the two numbers together. It's that easy, but it's more real-life examples. So do well. Pay attention to your labels. If it's area, make sure the label is squared. If it's a base or a height, make sure your label is not square. Do well.